Good morning, good afternoon, or good evening, depending upon where you live around the world. This is just a bit of an update to let you see where I'm at with the drawing and my thoughts on the HUBS, which seems to be occupying my thoughts of late. I'd mentioned about using the circular hub, which is still probably number one in my list. Then I wanted to develop the angled hubs, which I could see the complexity of its construction. And then I thought, I like the idea of having square cut ends to the struts. Okay. You don't need to get the angles as accurate, and it's not the angles that are the problem. It's when they all have to join at a specific point that all those different angles, to my mind, could start to create a little bit of an issue. Maybe I'm wrong. Then I thought, oh, hang on, I've got a bit of an issue about the engineering, about the attachments of the hubs and struts. Even my preferred circular hub, which is just basically a heavy walled metal pipe, probably 100 millimeters or so in diameter or bigger, but getting sufficient fixing into the end grain of timber is always problematic. I've seen where they've, and similar to what I've got here, which I'll zoom in soon, I've seen where they've got a saddle, a U-shaped saddle that goes around the strut and attaches to the metal hub, the tube. But again, it's that attachment, because the piece attaching to the hub and the legs of the saddle, I will zoom in because this is an example. Say that there, so that's what I'm calling a saddle. The angle actually has to be, the attachment has to be angled. If these were on the other faces, this one here is a simpler version because it's on the top edge. But these relative, how am I saying? When this part here attaches to the hub, it has to be angled to move onto the hub. I'll just see if I can move this out. Move here. Let's make a copy. But if we moved it out here a little bit, I'll just explode this. See whether I can. Whoops, wrong thing. I exploded. Hint to self: don't go and exploding the wrong things. Explode. Delete that. But as you can see, the plate will be angled to the hub. Now this is not perfect orientation, so even this version has to be angled and created. This would be the least or lesser complicated version, and if you had to have them on the sides, that would be a more complicated version, more fabrication, more cost, more complexity. So I thought, why can't we have this? And this is not a new, it's definitely not new. This is where I got the idea from the pictures I've got on the web. But I wanted to do it so that I could lower the surface of the hub so it's flush. I could alter, if we need to put dihedral angles on the hub, on the struts, we could do that just by reducing the leg of the hub. Reduce the depth, because if you had to come down here extra 5 millimeters on an angle for your cuts, then making this narrower solves that problem. It just drops it down below that point, so it's not going to be sticky up here. Although, I'd stay with that. Okay, so, and then part of this examination was how do we create these cuts? Because some of the angles on the timber, sorry, I'm getting a bit ahead of myself. The metal, which this is, I'm just indicating it's 6mm plate, you'd have to cut them at the 79.3 degrees. How do you go about that? Well, you could go to a engineer and get them to do it, or a laser cutting company, and they'll do it. They'll give you some really nice output. But it's the cost of that. But seeing it's a project and it's not a huge number of them, that should be able to be done reasonably easily. And I thought, no, I'd like to be able to at least do most of the work myself, get a certified welder to do the welds. That's for certain. You wouldn't want to have me doing anything that's involved welding, that's for sure. But I thought, well, hang on. If we've got offcuts of timber, we cut them at the required angle for the position, and then you can run a hand grinder if necessary, or even set it up in a chop saw where the angled timber can be the guide to set up the stops on your chop saw, and then you put your plate in and away you go. You can cut them at the exact angle to fairly much to the 10th degree, or 10th of a degree, in your shop-based, your home-based workshop. I thought that was good. Also, you make up a template so that it goes on the face of the timber, so it'll be all of the wings of the hub will be identical in length up to the point of the cut. So at the bottom they would technically be all the same length back. In this case it's 150 millimeters. You make up a template that goes on the strut, and you can pre-drill the holes, because the holes that will be drilled in the wings will be exactly the same, so you can then put your bolts through it accurately. So that gives you your strut length accuracy. I think that's a really good way of doing it. Now the question is, how the heck do you weld these correctly? And that is also taken care of in a home workshop by setting up a jig, and that's one of the projects I'll be working on soon, is that we have to create a very accurate adjustable jig, and anything that's adjustable is not always accurate, so it has to be robust and simple enough for the home workshop to use. Then you can hand everything over to your welder, and they can assemble the hubs and weld them up correctly. Then you bring them back, get them galvanized or painted or whatever you want to do for rust protection, and away you go. Do I think that's possible in the home workshop, or do I really think that? Well, yes, I do. That means that other than the welding and the plating of the hub, you should be able to do everything with the skills you've already got woodworking wise, because all the jigs will be timber or light metal, and you've got what I think is a happy medium. They look quite good. Get them powder coated, coloured to whatever you want. The bolts through can be quite nice. You can have threaded rod with captured or dome nuts, or you can have the internal external threaded bolts, which probably are the most elegant method. Whatever is available to you to make this the mechanically strong attachment, better than any screws that go through a hub, because the end grain is the thing. And any builder that's worked with timber before knows that the end grain the threads the whole screws can pull out of the end grain with relative ease. It's not that you can't have screws, and I like the Spax brand screws. You can get massive ones. Excuse the phone trying to contact me. But the Spax screws can be very long. Problem is getting them into your dome as you're constructing it. If this was a tube, to get the screws in and to be deep enough into the timber is problematic. To get them in from one side, enter a hole that's drilled down the side of the tube, the screw will have to go at an angle. If you're coming up from the bottom, that's even worse, because just the way the hub and the strut orientate, the screw would be on a greater angle and therefore would have less penetrating depth. It would certainly be crossing the grains more, which is advantageous, and the two screws would be dovetailing themselves in, but the depth down the strut wouldn't be great. You could argue that there's probably thousands of domes already built with that method, but I'm not talking about small domes. I'm talking about as we go up the scale, that the loads become sufficiently worrisome that the attachments become increasingly an issue. And there was a Paul Robinson video where he showed the concerns, or dispelled the concerns of a commentator to his website, his blog, about how the assembled triangles could pull apart. And the person making the critique was looking at it too much zoomed in and assuming the two components of one triangle were the loads, whereas, as Paul showed, no, you've got to look at the entire hub, where there is opposing members of many triangles, and they become very strong and neutralize each other. And he's dead right. But you can't then say, well, it's obvious that domes are super strong and therefore have no problems with the pulling apart of the hubs and struts. Well, I beg to differ, and this is if you can, I'll just try and orientate it around. This is the bottom hub at the foot that let loose, with no doubt catastrophic failures due to, what was it, snow? By the looks of it, there was snow. Was it wind? Well, could it have been snow load and then wind? Or could it have just been excessive wind? For it to deform in the manner and collapse, I do find quite odd. This one here looks like it's completely gone. This one's still attached somehow because it's on the angle to create still in its dome-like angles. But the person creating this obviously went to some length to get the dome well built, and has had made, or has had supplied, a very chunky hub. The mounting points for the hub, that's great. It's through decking, so it would have to be into the subfloor framing. Okay, all nice and strong. Obviously, the hub manufacturer understands the energies going into the dome, but the attachment points looks like a bit Heath Robinson. These are what we call nut couplers, and they are designed for joining two threaded rods or two bolts. And they're they're not very long. The ones that we use are probably 30 to 40 millimeters long, maybe a bit longer. And then he's got 2, 4, 6, 8, 10 screws, which were only probably 40 millimeters long, if that. And you can see the effect that I was talking about, how the threads don't hold. They glove. The fibres just encase around the thread and they pull out. Very, very little pressure required for that. And whatever epoxy or glue that they used to attach really wasn't enough, was it? Obviously. How many of these would fail like this? No idea. Was this the only one in the entire world? No idea. But you can see that this was an attempt to make a good job, and really you'd be thinking that all the pressure is coming down and therefore there would be no upward pressure. Well, of course there would be. The dome is a huge catchment for wind, and the reverse parachute effect, as I refer to it, has to be a substantial factor. Now, were they going to rely on the fact that the cover that they're putting on hook onto these attachments here, these eyes here, and that the tension achieved by the cover and the cables would hold it down? Well, maybe that was one of their considerations, but it should have not been part of their engineering perspective. The dome structure should be independent of that. Anyway, it failed, didn't it? And they wouldn't have been happy about that. And was there a chance of injury or to human, to bodies, or even damage to property? And that, as a builder, we have to consider, and why we can't go around assuming when we build something, especially for someone else, that the attachments will be just fine, and I can't indemnify myself as a builder for using a process of attachment or a method or even a component unless it's been specified and meet a standard. That standard has to be approved by the local jurisdiction and come with the appropriate certification. Hence why I'd be wanting an engineer to step in, say yes, this will be strong enough if welded by a certified welder, and then I could go ahead. I've now got the paperwork, a paper trail, saying that I've done my due diligence. I have had them manufactured in an appropriate manner, and they meet Joe Blogg's engineers' standard of design. We've got a big issue in my country where, through trying to save money, people will swap out a specified component or item for another equivalent, but that equivalent may not have the specifications attached to it that meet the requirements of the local jurisdiction. I've done it myself, where we've swapped one specified product, in this case it was a plywood cladding, for another. It had a standard, but even then, did it meet the actual requirements of the engineer who could have had a finger in the pie of designing the bracing for the building? I've had a situation where the bricks for the cladding, one would meet the specific standard, the other wouldn't, and you think, well, they're bricks. But we don't necessarily know all the design requirements as builders or carpenters or whatever you are in the trade for the different components. It may well be that these would not suit within 500 metres or 5 kilometres of a shoreline because of the corrosion resistance requirements. So if you put one in close to a coastline, it corrodes, there's some issue for longevity or the structural integrity, you could be up for great strife. Now, if you build it for yourself, you've got to then be careful, which you can. You've got to then be careful if you on-sell your property and this is a structure on the property, because you've effectively become the builder and engineer if you've built them yourself. Now, this may sound like a person that's a bit of a worrywart, because I see things being built on a lot of the build programs on television, and I just shake my head. I just don't know how you're allowed to do that. So obviously the different countries have different codes that permit a bit of latitude. So if you're just listening to this and shaking your head and say it doesn't apply, that's great, bang on ahead. But you can't not underestimate, but you must consider at least some of these issues, I think. Okay, so that's me. I've prattled on way too long, but the hubs took a lot less to talk about than my concerns, so which one was more important? I'd go with the concerns on that one. Okie dokie, that's it. I'm off. See you later. Bye.